Ford expects to boost its global electric car production capacity to 600,000 units by 2023, making it the second-largest U.S. electric vehicle producer after Tesla. But to do so, Ford must conquer the battery supply chain. The American manufacturer has announced that it will be upgrading the electric vehicles it produces with a new LFP battery composition that will boost capacity and reduce manufacturing costs. But how does Ford intend to achieve this massive feat? Join us today as we take you through Ford's new lithium iron phosphate battery that has shocked the entire car industry. Before we continue, we need to know what LFP batteries are and the difference between the current industry standard NMC and NCA batteries. NMC nickel cobalt manganese and NCA nickel cobalt aluminum have been the gold standard for years. They are lightweight, powerful, and can hold lots of energy, allowing for longer ranges. However, there are two big drawbacks. They can be flammable and they also use exotic and increasingly expensive raw materials. These include nickel, cobalt, and manganese. Due to increased competition in the EV market, prices have risen ninefold from $6.75 per kilogram in early January 2021 to over $40 per kilogram in 2022. The big difference is that LFP does not use the same expensive raw materials. Instead, they use lithium, iron, and phosphate chemistry. Early LFP batteries were significantly less powerful than NMC and NCA alternatives. They were mainly used for e-bikes and low-end EV brands. Despite their potential benefit of being less expensive, they couldn't achieve the results needed to compete. LFP chemistry accounted for just 3% of EV batteries in the US and Canada in 2022 and 6% in the European Union, with nickel cobalt manganese, NCM, cells accounting for the rest, according to data from Benchmark Mineral Intelligence (BMI). In May 2021, China produced more lithium iron phosphate (LFP) cells than nickel cobalt manganese (NCM) cells for the first time, marking a significant milestone. This signaled that the benefits of LFP batteries were beginning to outweigh the drawbacks that had previously held back their global adoption. In order to compete on a global scale, Ford must secure sufficient supplies of the raw materials needed for batteries. This is why they have agreed on a huge supply deal with China's largest LFP manufacturer for lithium iron phosphate batteries beginning in 2023. The cost and longevity of LFP batteries have made them particularly popular in China, where affordability and reliability are more important to customers than overall driving range. Because iron and phosphorus are abundant almost everywhere in the world, LFP cells are at least 30% cheaper than other options, including NMC, NCA, and NMCA cells used in many EVs today. Compared to nickel-rich batteries, LFP batteries last much longer. They can be charged and discharged hundreds of times without losing much power. CATL has confirmed that its LFP cells can go 1,000,000 kilometers before needing to be replaced. Nickel-rich cells, on the other hand, are approximately 30% less efficient. Nickel prices have doubled over the past year, mostly due to the conflict in Ukraine. Right now, Russia provides about 10% of the world's nickel, and 20% of this nickel is used in EV batteries. Many automakers have had to increase the price of EVs as a direct result of rising raw material costs. Ford, for instance, has already increased the price of its F-150 Lightning twice this year. The starting price of the 2023 Lightning Pro model will be $51,974, up nearly 11% and a 30% increase from the truck's $40,000 price in May 2021. Even though LFP cells have less energy density than nickel-rich cells, this problem can be mitigated by using new cell-to-pack structural designs. These designs eliminate the module structure, allowing more cells to fit into the same space. All Tesla Model Y and Model X vehicles made in China over the last 2 years have been fitted with LFP batteries, as Chinese buyers prioritize durability and price over range. Tesla then shocked everyone when its Q1 results showed that nearly half of its vehicles produced that quarter were equipped with LFP batteries containing no nickel or cobalt. Tesla confirmed in a statement that it has now shifted to LFP batteries for all standard range vehicles globally. Like Tesla, Ford will likely use LFP batteries for its standard range vehicles while continuing to use NMC batteries for its extended range packs. CATL is the largest provider of electric vehicle batteries in the world, supplying LFP cells to both Tesla and Ford. Ford has confirmed that LFP batteries will be used in some Mustang Mach-E models beginning in 2023, and the first iron phosphate-equipped F-150 Lightnings will roll off the assembly line in early 2024. Ford must take these steps to reach its goal of producing 2 million EVs per year by 2026. The first production will come from CATL factories in China. However, Ford plans to localize 40 GWh of LFP production in North America by the end of 2026. This will be in addition to the 129 GWh of NMC that will come through its joint venture with SK On. Ford has already secured all the batteries it needs to meet its goal of producing 600,000 cars by the end of 2023, thanks to the inclusion of CATL's LFP batteries. CATL has also signed a contract with Ford to supply 70% of the batteries needed to reach its goal of 2 million EVs by 2026. To lead the industry, Ford must ensure access to all necessary raw materials. This is why Ford is investing directly in securing materials, much like General Motors, Volkswagen, BMW, and other companies have done. It has supply agreements with BHP and Vale Canada and PT Vale Indonesia for its nickel. Additionally, Ford has agreements with Liontown Resources and Rio Tinto, both based in Australia. Due to supply chain challenges over the past 2 years, Ford is also working to secure cathode materials like lithium closer to home. This demonstrates the risks of relying on a single supplier. EcoPro BM and SK have signed agreements to produce cathode materials for Ford. The company also has contracts with Pioneer and Compass Minerals to source lithium from North America and with Sierra Resources and SK to obtain graphite from a factory in Louisiana. Ford has also partnered with Redwood Materials to recycle its batteries. Ford CEO Jim Farley is doing everything he can to ensure Ford does not fall behind in the electric vehicle revolution. In a recent CNBC interview, he stated, "We're not going to cede the future to anyone." Since range anxiety has been a key factor in EV consumer purchasing behavior, NMC-based EV manufacturers have focused on developing more energy-dense cells. However, as nickel and cobalt have become supply bottlenecks and EV drivetrain efficiency has improved, less energy-dense LFP batteries are becoming viable alternatives. As a result, NMC batteries are losing market share to LFP batteries. Research also suggests that neighborhood electric vehicles with shorter ranges will gain market share, further reducing demand for energy-dense NMC batteries. Ford's switch to LFP batteries may not completely prevent future material shortages, as lithium itself could become a bottleneck. However, if history is any indication, battery chemistry will continue to evolve as scientists seek the most cost-effective way to meet market demand. What do you think of Ford's latest move? Do you care more about range or price? Let us know in the comments below. Thanks for watching until the end. If you haven't yet, please consider subscribing to our channel so we can keep you up to speed on Ford, Tesla, and EV news.